Anything that gets in between a student and pencil and paper is detrimental to the learning of mathematics.
Today we have Professor Jim Davis, who is the instructor for Calculus II, also known as Mat 195.
I am a graduate of the engineering science program, which I entered in 1978, and in 1982 I graduated from the aerospace option. After that I went on to graduate school at the Institute for Aerospace Studies, where I completed a master's and a PhD. My research area is in materials for fusion reactors. This is an area I got interested in when I was actually an undergraduate student, and I spent 2 summers working up at UTIUS in the research lab, which I now run. And this whole time I've been looking at various aspects of how very high temperature plasmas in a fusion reactor interact with the materials that are intended to keep the plasma from escaping.
Tell us why you're passionate about teaching.
The reason that I've enjoyed teaching calculus goes back to high school. Like all of you, I was very good at high school, but I found the subject of physics very troubling. It seemed to be just a collection of random disconnected facts. Then I discovered calculus. We had a very good calculus instructor at my school, and we did a very comprehensive course in calculus. And what I discovered was that all of physics really came down to one equation, F equals ma, with calculus. And this led to the whole subject of physics becoming a comprehensive single subject. And everything from things like the Bernoulli equation governing fluid flows to the rocket equation governing how big rockets have to be, it's all just F equals ma with calculus. And this has led me to really enjoy various aspects of calculus, and in particular, teaching calculus.
What is your favorite or the most unique thing about your course?
There are several parts that I quite like in Math 195. The first part has to do with infinite series. Infinite series are really interesting things, and they have some very strange properties. And it's something that it's useful to make students really think about mathematics and some of the fundamental aspects of what they've learned. So it's always a lot of fun going through some of this material. The other thing that I like, and this is particularly from the perspective of an engineer, is when we start doing the translation from single variable calculus to multivariable calculus. And all of a sudden, we can do all of this mathematics, but now in 3-dimensional space. And this, to me, is a really beautiful thing as well. Being able to do this, applying calculus, rather than just in an abstract way, but to apply it to the real 3-dimensional engineering world.
What should students expect in your course?
What they should expect is a continuation of the first term calculus, Math 194, with a lot of the same properties. We will cover material very quickly. The beginning of the course, simply techniques of integration, is very mechanical. We go through it very fast, and then we start doing some more interesting things, which we take a little bit more slower. Ultimately, it depends on the students doing the work. There's no graded assignments sets again, but there are assigned questions, and the expectation is that students will do all those assigned questions. We have weekly quizzes to try to get students to do the homework. That's really what the objective is there, along with a couple of tests. The bottom line is always that the student will only learn by doing. You're not going to learn by reading the textbook. You're not going to learn by attending the lectures alone. You actually have to do the work. And that's the only way that you'll be able to learn this material.
What concepts in your course do people tend to struggle with the most?
The one thing that students really do tend to struggle with is setting up a proof. Setting up a logical train of thought that leads or directly leads from a premise to a concluding statement. It's something that we ask engineering science students to do that regular engineering students don't, but at the same time our students don't get the same background in it that, say, pure math students do. But it's something that really does require a particular way of thinking about a situation. The mechanical stuff, most engineering students can do pretty well, but once we get to the less direct things, the more abstract ideas, those tend to require a little bit more thought, a little bit more effort in terms of learning, and those are the places where more students find challenging.
What available support do you have for students in your course?
I think the greatest support that students in Math 194 and 195 have is the textbook that we use. The textbook by James Stewart is a fantastic book. It does a really, really good job of presenting the ideas in a very intuitive way, and it, just comparable to the books, or compared to the books from 20 and 30 years ago, it really is a fantastic book to work with. Aside from that, we have tutorials weekly, and as I mentioned, we have quizzes every week to try to get people to do the assigned questions. Again, it's bribing people with marks to do what they should do on their own, but that's how it works. There are also, and these are very useful for some students, the Engineering Science Office organizes study sessions, which can be directed to various courses, but before tests they would be in particular subjects, and there are often upper year students who are available to help in those sessions. So those are a very good resource as well.
Do you have any closing remarks or anything else you want to say to the incoming class?
I think the one remark is a quotation from a math professor who I used to co-teach Math 185 with, and that is, and it has to do with technology to some degree. And the quote is that anything that gets in between a student and pencil and paper is detrimental to the learning of mathematics. And I think it's important that students recognize that and realize that the only way they're really going to master the subject is with pencil and paper.
Concepts in your course people tend to struggle with?
Oh, that's easy.
Okay.
What's the answer to that question?
Should be, what, integrals? Infinite series?
No.
Doing the homework.
Oh,